Alright, I'm going to just walk you through a few more examples of simplifying these trig expressions. Try to follow my thought process as I analyze these and use different strategies to simplify them. So let's start off with secant x minus tan x sin x. Alright, looking at this first, I want to see, can I factor anything? Well, these have nothing in common. Secant x over here, tan x, sin x over here, so I can't factor. Next, I would rewrite this using sine and cosine functions. So secant x is going to turn into 1 over cosine x minus tangent x. That's a quotient identity. That's going to be sine x over cosine x. And my sine x, I can leave that as it is because it's already using sine. Now that I've got my problem rewritten using sine and cosine, let's see what we have here. Well, I have common denominators of cosine x, and I also have sine x times sine x up here, which would be sine squared x. So I'm going to go ahead and combine my fractions. That's going to give me 1 minus sine squared x all over cosine x. Looking at my 1 minus sine squared x, I see that that looks like a Pythagorean identity. Going up here, if I subtract sine x from this side, that's 1 minus sine squared x, leaving me with cosine x. So I can replace the top here with cosine squared x. That'll give me cosine squared x all over cosine x. One of those cosines is going to cancel, leaving me with just a straight answer of cosine x. Let's do another. Here we have negative secant x minus tan squared x secant x. Looking at these, I see both terms have a secant x. That means I can factor. I'm going to factor a secant x out. That's going to leave me with a negative 1 minus tangent squared x. From here, inside my parentheses, I have a negative 1 minus tan squared x. This should remind me, since I have a 1 and a squared trig function of my Pythagorean, this involving 1 and tangent is 1 plus tangent squared x equals secant squared. Here I have negative 1 minus. So what happens if we factor out a negative? I'm going to change this to negative secant x. That's going to leave me with 1 plus tangent squared x. From here, I know that 1 plus tan squared x equals secant squared x, so I can replace that right there. That's going to leave me with negative secant x and secant squared x, replacing my 1 plus tan squared x. Since these are both secant, I can just combine those. Negative secant x times secant squared x is going to be negative secant cubed. Oops. That should be a cubed. Negative secant cubed x. Let's do another. Cosecant x over 1 plus secant x plus cosecant x over 1 minus secant x. Here I'd start by definitely combining these fractions, which means I need to get common denominators. My common denominator is going to be 1 plus secant x and 1 minus secant x. The left side here is missing the 1 minus secant x, so that's what I'm going to multiply to the top and bottom. And the right side has a denominator of 1 minus secant x. That's missing 1 plus secant x, so I'm going to multiply 1 plus secant x to the top and bottom. Alright, going from there, I'm going to fast forward and distribute everything out. Whew! After all that, I'm going to be left with this big thing right here. Now that I have common denominators, let's go ahead and combine those together. That's going to leave me with one big denominator of 1 minus secant x, 1 plus secant x, and in the numerator I'm going to have cosecant x plus cosecant x. Those are like terms, so I could combine those, leaving me with 2 cosecant x, and I have negative secant x cosecant x plus secant x cosecant x. Those are going to cancel each other out, so we're just left with all of this down here. Moving forward, this cosecant x is not really canceling with anything at the bottom, so let's go ahead and distribute out the denominator and see what we're left with. Especially since I notice that these are conjugates, that might be a clue I'm going in the right direction. Distributing all that out is going to leave me with 2 cosecant x all over 1 minus secant squared x. Alright, teleporting back to the top here so we don't get too far away from our identity tools. I see that 1 and secant squared x should remind me of my Pythagorean identities. 1 plus tangent squared x equals secant squared x. Let's see what we can do here if we can manipulate it so we can replace this denominator here. Alright, using that we have 1 plus tan squared x equals secant squared x. If I subtract secant x to the left, I'm going to get 1 minus secant squared x, and subtract tan squared x over to the right, that's going to equal negative tan squared x. So I can go ahead and replace my negative tan squared x for my 1 minus secant squared x. That's going to leave me with 2 cosecant x over negative tan squared x. Alright, I don't want this tangent squared x in the denominator, but I could use one of my reciprocal identities to move this to the top, right? Tan squared x on the denominator is just like 2 cosecant x times 1 over tan squared x, and I'm just going to move my negative out into the front here. So 1 over tan squared x I can replace with cotangent squared x. So let's give ourselves some room here. That's going to leave us with 2 cosecant x, and don't forget my negative out in front, and 1 over tan squared x, that's just going to be cotangent squared x. And there we have our problem simplified into one term. Let's try one more of these. Here I have cosine squared x over 1 minus sine x. Now this is already written as one term, so I can't combine fractions. It's already written as sine as cosine, so my best option might be, let's try to reduce this term out by multiplying by the conjugate. That'll be 1 plus sine x, because we want to do the opposite of whatever the denominator is. That will leave me with cosine squared x times 1 plus sine x all over 1 minus sine squared x. Here I see this 1 in sine squared x, so I should be thinking Pythagorean, and I can replace this right here with cosine squared x. Doing that, oh, looks like things are going to work out nicely. These cosine squared x's can just cancel each other off, and I'm simply going to be left with an answer of 1 plus sine x. The more you do these, the better you're going to get. There's certain clues that you'll learn to pick out and say, okay, well, this means I need to do this. This means I should use my Pythagorean identities, etc., etc. So make sure you have all your identities on hand, and as you practice more and more, you'll start getting quicker and quicker in working these out into a simplified answer.